All right, so we want to look at inverse functions, and I have here two functions, g and f, okay? Here's my function f that's going to take these values here and map them over to its range. See, here's the domain of f in this circle. Here's the range of f over in this circle. And f takes a value of x and it maps it over to some value f of x. Okay? But then I've got this other function g. And g takes values from this set. See, here's the domain of g right here. And it takes values here and it maps them over to this set here. And this set here is the range of g. Okay? But notice how these two functions work together. F takes x and maps it to a value. G takes that value and maps it back to the original value, x. Okay? And that's that g of f of x equals x that we were talking about. Okay? G of f of x equals x. That's what ends up happening. Okay? If they are inverses. Okay? So let's look at this definition of an inverse. F and g are two functions such that f of g of x equals x for every x in the domain of g. Okay? And g of f of x equals x for every x in the domain of f. Alright? Now we showed the second part right here in the picture to the right. Okay? This right here is illustrated by that mapping diagram. Okay? Now, there's a little bit of notation that you should be familiar with. A lot of times, once we know it's an inverse, then we use notation for an inverse. And you've actually seen this notation before. You may not have realized what it was, but you've seen it. And that is this little -1 right here. Okay? Let me zoom in on this. This little -1 is not an exponent. Okay? It means inverse. It means inverse. So when I see f -1 like that, I read it f inverse. Okay? Now,
isn't it the same as 1 over f?
It's not. That's why I said this is not an exponent. Okay? F inverse is not the same thing as f to the -1 power. If I wanted to take 1 over my function, then I would do f of x to the -1 power. That would say take the reciprocal of my function. Okay? But when you see the -1 right by the f, it's talking about an inverse function. Now, can anyone remember where they've seen this before?
The sequences.
Yeah, probably. Oh, never mind. Wait, I'm thinking of something else.
Isn't it where you like switch the y and the x, or?
We do end up doing that, and we'll look at that to actually find an inverse. Look at your calculators. Sine, cosine, tangent, yes. I don't know how much you guys have used those up to this point, but yeah, you see the sine button on your calculator, okay? And if you hit second sine, you see the little sine -1. That's not a reciprocal button, that's an inverse sine. And here's how it works, okay? Here are a bunch of angles. And then here's a whole bunch of different values. And for sine, they would be values from -1 to +1. Okay? And sine takes an angle like 30 degrees and maps that to 1/2. Okay? But then if you do that inverse sine or arc sine using the 1/2, guess what it gives you? It gives you the 30 degrees. Okay? So you've actually seen it, maybe you didn't notice it on your calculator before, but it's right there. Okay? That's that same notation. Now, we're not going to be doing this with sines and cosines and tangents yet. We'll get to that in Unit 5. But it is the same principle that's used there on your calculator. Okay? Now, I'm going to... Let me get rid of that. Okay. So let's look at some functions that are a little bit simpler and see how they are inverses of each other. Okay? So I have f of x is 2x and g of x is x divided by 2. Alright? You guys learned inverse operations. And the inverse operations, multiplying by 2, dividing by 2. Okay? Well, let's look at this. F of g of x means that I'm going to take g of x, which is x divided by 2, and I'm going to plug that into f of x, which is 2 times something. Okay? So the something here happens to be g of x. Alright, well, if I simplify that, 2 divided by 2 is 1, so that just equals x. Okay? If I do it the other way around, g of f of x. G is something divided by 2, right? Well, in this case, the something is going to be the f of x, that 2x. Alright? I'll just put it in parentheses to kind of highlight that's the function that I'm plugging in. Well, now 2 divided by 2, again, just gets us back to x. So there's a proof that f of x and g of x are inverses of each other. Okay? So, first of all, we can flip anything over the line y equals x, right? However, that doesn't mean it's going to be an inverse function. Okay? Because you guys know, to be a function, every x can only be mapped to one value of y. Okay? In other words, if we have directions, like a function here, that tell us how to get somewhere, following them backwards may not get us exactly in the right spot. It may end up in 2 different spots. Okay? So for example here, f of x equals x squared is this parabola right here in blue. Okay? Here's f of x equals x squared. And the inverse operation of the square is the square root. Okay? However, as you guys know from solving things back in algebra, if you take the square root of, say, 4, there are 2 different possible answers. Okay? I could have positive 2 or I could have negative 2. And you can see that with these points right here. Okay? So I start with the point negative 2, 4, but when I try to go backwards and I take the square root of 4, I could end up at positive 2 or I could end up back at negative 2. Alright? So in this case, these would not be inverse functions. Okay? I actually have to do something else first in order to make it an inverse function. Okay? I have to force it to be 1 to 1. Okay? Now, the only way I could do that is going to be by limiting the domain, and we'll take a look at that in a second. Alright? But what 1 to 1 means is every element of the range only has one element of the domain mapped to it. Okay? So for example, we said that to be a function, every x could only be mapped to one y, but it was okay if multiple x's had the same y value. Like it was okay to have the point 3, 4, and 5, 4 on your graph. But it wasn't okay to have 3, 4, and 3, 2. Okay? In order to be one-to-one, all of them have to have just one thing mapped to it. Okay? So you can't have 3, 4, and 5, 4. That would not be one-to-one because you have two different x's mapped to 4. Alright? Now, it's very easy to see this on the graph because we have the horizontal line test. Okay? The horizontal line test says that if we can pass any horizontal line through a graph and intersect it more than once, it's not going to be one-to-one. Okay? And if you think about it, it makes sense. Alright? Because if I can't pass a horizontal line through it and only hit it once, then when I flip it across the line y equals x, when I reflect that, I won't have a vertical, I'm going to have a vertical line that hits it more than once. Okay? So basically we're saying, hey, why bother reflecting it in the first place if we know that it's going to end up getting hit twice? Hello.
I have a question.
Yes.
Why can't there be two horizontal points and one vertical?
There can be on a function. Okay? This is okay for a function. But
Or sorry, two vertical points for. No, wait. Split up.
like, why can't you have this and this for a function?
Yeah.
That's the definition of that's what distinguishes a function from just a relation. A relation is any equation that has multiple variables in it. Okay? But a function is a specific type of relation where we never have this happen.
Why?
That's just how we've defined it. And it allows us, the reason why we look at those specifically is because it enables us to do a little bit more and there's no uncertainty. You know, when we plug it in, we know exactly what a value is going to be, not, oh, it might be this or it might be this.
Okay.
Okay? Yes?
So if it doesn't pass the horizontal line test and it's not one-to-one, you can't really find a function, is that what you're saying?
You cannot, as it is right there, you cannot find the inverse function. Okay? You could always flip it, but when you flip it, it's not going to be a function. Reflected across the line y equals x. Sorry. Now, one thing I could do to this is I could limit the domain. I could say I'm only going to look at f of x squared when x is greater than or equal to 0. Okay? If I do that, notice I've eliminated this whole half of the graph. And when I reflect it, that's going to eliminate all the negative outcomes. Right? So now, this is just a function. Okay? Because this is now one-to-one if this left-hand side of the parabola doesn't exist. Okay, it'll pass the horizontal line test if I get rid of the left side. And if I do that, then this will pass the vertical line test now. Because that got rid of the bottom side. Does that make sense?
I'm sorry, what do you mean by one-to-one again? I'm sorry.
One-to-one means that every y, everything in the range, only has one x being mapped to it.
Okay.
So like here, you had y equals 4, but there were two different values of x that were getting mapped to 4.
So, like, basically, it's any quadratic wouldn't pass that.
Yeah, any quadratic, unless we limit the domain somehow,
Okay.
then it's gonna fail the test. All right. And we'll look at limiting the domain to make it work. Okay. So, how do you find the inverse? Well, here, if you understand the reflection across the line y equals x, okay, it's real easy to remember here. What happened to all your points when you reflected across the line y equals x?
Oh, yeah.
What?
It looked like a 90-degree rotation, so the x values turn negative.
That's a different kind of thing. That's a... Yeah, that...
Oh,
Not
they
exactly.
become the reciprocal.
Not reciprocals.
Opposite.
If I had the point 4,5 on my original, then when I reflected it across the line y equals x, what did that point? It became the point 5,4.
Yeah,
All the x and y coordinates switched.
isn't that the reciprocal?
No, because that would be 1/5, 1/4.
Oh,
Okay.
That's what I meant.
Oh, okay. So here, okay, here I have f of x is 3x plus 7. If I switch the x and y, all right, so instead of y is 3x plus 7, I make it x is 3y plus 7. That will enable me to find the inverse, okay? Now, real quickly here, we're going to fill this in as we go. What is the domain of our f of x here? X is... all real numbers, okay? X is all real numbers. And what's the range then? All real numbers. So y is an element of the real numbers as well. Okay? So now as we solve this, we subtract 7. We divide by 3. Okay? So we could say now that f inverse of x is x minus 7 over 3. Okay? Is that a function?
I remember this one so good.
You remember now?
No, yes.
Okay.
I hated this.
Okay. Some of you remembered this. Well, is that a function? Yeah, what kind of function is that? It's a line, right? It's linear. Okay? By the way, if you have a linear and you flip it, you're going to still have a linear. Okay? So what's the domain of this? All real numbers. And the range? All real numbers. By the way, for lines, unless it's a horizontal line or a vertical line, the domain and range is always going to be all real numbers. Okay? All right, good. So let's look at G. For G, we have 5 plus the cube root of x. Real quickly here, the cube root, remember, this wasn't one of the parent functions you have to have memorized, but remember it looks like this. Okay, so what's our domain?
All real numbers.
All real numbers. And what's the range?
All real numbers.
All real numbers. Okay, and actually this one would be this shifted up 5, but I didn't draw the shift. Okay, so now if we switch the y and x, we now make it x equals 5 plus the cube root of y. Okay, so we subtract 5, and then how do we undo the cube root? Okay. Raise it to the third power, cube it. So y is x minus 5 quantity cubed. So guess what? G inverse of x is x minus 5 cubed. What's the domain and range of a cubic function?
All real numbers.
It's all real numbers. Okay. Now, I'm actually going to change this one example. All right? I want to make this I want to change this from 8x cubed to 8 times the square root of x. Okay? I want to change this example here. 8 times the square root of x. What is our domain for 8 root x?
Greater than 1.
No?
It's
What, Lingshan?
Y.
greater than equal than 0.
Very good. X has to be greater than or equal to 0. Okay? What is the range?
0 to positive infinity.
Okay. 0 to positive infinity. Remember the radical function starts at the origin? Okay? So we have that. What would it be if I had 8 root x plus 2?
2.
X, or Y is
0.
greater than,
Wait, are you talking about domain?
Y is greater than.
Well, would adding 2 like that change my domain?
No. But it was
No.
just the range.
It would change the range. What would my range be now?
Y is greater
Positive
than
infinity.
Y is greater than
2.
or equal to 2, right? Okay? Now, let's find the inverse. I'm going to switch the x and y. So now it's x equals 8 root y plus 2. Right? So I've got to solve. I've got to subtract 2. 8 minus 2 equals 8 root y. I divide by 8, so I now have an x minus 2 over 8. And then what do we do with that?
Square.
We square it, good. So y is, we could just leave it as x minus 2 over 8 squared. But what kind of function is that going to be? It's a quadratic. Now what's the domain of a quadratic? All real numbers. However, if we're doing this as an inverse, the domain of this has to be the same as
What we said before, it has to be greater than 0.
the range of the original function. Okay? This is where people go astray a little bit. And it wasn't as noticeable in the first two examples, because everything was all real numbers. Okay? But technically, the range here was the domain here. The range here was the domain here. And the domain here is the range here. The domain here is the range here. So, if h inverse of x, if we want this to be an inverse function, we can't use the normal domain and range for the quadratic function, can we? We have to use the domain and range from our original function, which was a radical function. Okay? So, we're going to now say x is greater than or equal to 2. That's our domain. Okay? And our range would be what?
Greater than or equal to 0.
Good. Y is greater than or equal to 0. Okay? Does everyone follow that? You understand?
Yeah.
Okay? So, really, really easy to make that mistake. If I ask you for what the domain and range is and you see a quadratic, if it came from a radical function, you got to be careful. Okay? So, now, I gave you some practice, alright? I gave you some practice with this. This is not all the required IP. Some of these are, so make sure you, excuse me, make sure you look at those, okay? Do the required IP and come with questions, alright? They do ask about domain and range on some of those, so be careful.